In this tutorial, I'm going to talk to you about what statistical analysis that can be used to analyze the Likert scale surveys using the knowledge, attitudes, and practice theory that is known in short as CAP. So we start first with a theoretical framework or conceptual framework like this, meaning that we have some variables or constructs as we call them, and we have the relationships between these variables, like as you can see, h1 standing for hypothesis 1 and h2 standing for hypothesis 2. Then we have these variables, usually from the left they are the independent variables, predictor variables, and the variables on the right are known as the dependent variable or the outcome variable. If there are variables in the middle, usually they take the roles of mediator, moderator, etc. So we have this theory of CAP and we want to test the relationships between these variables. So here we have two research hypotheses. The first one, it says that knowledge has a statistically significant positive effect on practices. And the second hypothesis says that attitudes have statistically significant positive effect on practices. So here the research procedures, we start with a 5-point Likert scale through Google Forms or Qualtrics, depending on the web-based tool that you are using. Then data sample, here we have mostly convenience sampling of 100 to 200 students or respondents. So this is called non-probability convenience or voluntary sampling, where you share the link and respondents just fill out the questionnaire. For the data analysis, we can use tools like Excel 365, SPSS, AMOS, Smart PLS, Implus, Jamovie, JASP, R, RStudio, among others. So for the results, we have construct reliability and validity. So for the results, we have construct reliability and validity in addition to path coefficients of independent, dependent moderators. Sometimes we have control variables like age, gender, income, residency, etc. So after that, we investigate the reliability and validity. So we put each construct here along with the number of items that make up the construct in addition to the Cronbach alpha value that should be 0.7 and above for it to be good. Then we interpret the Cronbach's alpha here. These are different thresholds that can be used to interpret the Cronbach alpha in addition to the references that are used to do that. So usually it is acceptable from 7 till above, like good or excellent, depending on the coefficient. If it's not good, sometimes reverse coding procedures can be implemented to delete or reverse code the negatively ited items. This can also be used to improve the factorial validity of the scales. And if you are on species, there is this formula that can be used to reverse code a 5-point Likert scale. Otherwise, there is another procedure that can be implemented for the descriptive statistics. So here we have the scale from 1 to 5, the anchors strongly disagree to strongly agree, then the interval length, the lower limit, the upper limit, and the levels that can be aggregated, like low if it is from 1 to 2, moderate if it is 3, and if it is 4 and above, that's high. So these are the thresholds. We can also do a Likert item analysis by taking the ID, the items, the strongly disagree, and neutral agree, A, and strongly agree. 5, in addition to the M meaning the mean or the average, then SD meaning the standard deviation. With a not like under the table, we have strongly disagree, etc. The data analysis through descriptive statistics shows that the majority of respondents show high level or lower level perceptions. For the correlation analysis, as you can see, we have knowledge, attitudes, practices, and we put it in a table like this. The mean here, the standard deviation here, the 1, 2, 3. So these are the 3, let's say, variables. In addition to the asterisk that is used here to signify the different thresholds of the p-value from 0.05, 0.01, and 0.001. For the correlation coefficient relationship, according to Field 2024, so if the correlation coefficient is between minus 0.3 to plus 0.3, that's weak, negative, or only positive relationship, depending on the correlation coefficient sign. If it is between 0.5 and 0.3, minus or plus, that's moderate, negative, positive relationship. If it is 0.9 and from 0.5 to 0.9, that's a strong negative correlation or positive correlation. And if it is from 9 to like 0.9 to 1, that's very strong positive correlation. So these are the different stars. For 1 star, it means that the p-value is below or equal 0.05. 2 stars means that the p-value is below or equal 0.01. And 3 stars means that the p-value is below or equal 0.001. So according to Phil 2024 Discovery Statistics using IBM Species Statistics, for the regression analysis, usually we put a table like this. Let's say we put practice as the outcome variable, DV or dependent variable, and we put these two variables as predictors like knowledge and attitudes. We want to see to what extent knowledge of something and attitudes towards something could produce or could result in higher, lower practices. Frequency, so to speak. So we have the beta coefficients, we have the standard error, we have the beta, and we have one standardized, the other one standardized. We have t value, p value, and so for this one is like 54% of positive influence of attitudes on practices. That is statistically significant. So this is how we can go about interpreting, and we need to interpret the R-square for correlation or the variance explained by the independent variables, adjusted R-square, the ANOVA statistics that should be statistically significant, the Darwin-Watson test, etc. Sometimes we put also normality plots, and this is how we could go about it. So the ANOVA tells us whether the regression model fits the data or not. It should be statistically significant. Then the beta coefficients, which is this one, you can see how it's typed. So it's reported in addition to the p-value. So we report this one, and then we put the beta coefficients here in the arrows in addition to the signs that mean whether the hypotheses have been found to be statistically significantly positive or negative depending on their directional or indirectional hypotheses. So this is the reference, and then we operationalize the scale by putting, for example, the constructs. We call them constructs because they consist of different items. And then we put the operationalization, meaning the indicators or the Likert scale, strongly disagree, disagree, neutral, agree, strongly agree, like this. So each one maps, as you can see, directly to the variable that we have in the title, in the data analysis and everything. So this is like the questionnaire. Some universities, especially in the UK, in the United States, they require IRB, Institute Review Board. So that's why they require these statements about confidentiality, consent form, voluntary participation, risk, etc. to be supported. So these are like other types of questionnaires. Anyway, so this is in brief how we can go about analyzing and reporting Likert scale data, following especially the practices that are in academia and publishing. If you have questions or remarks, do not hesitate to post them below. See you soon. Bye for now.